All right. So, as with numerical fractions, the procedure used to add or subtract two rational expressions depends on whether the expressions have like or unlike denominators. To add or subtract rational expressions, which are fractions, with like denominators, simply add or subtract the numerators, right? You don't add or subtract the denominators, just the numerators on addition and subtraction, okay? And then write the result over that common denominator, all right? So if I have A over C plus B over C, or A over C minus B over C, I just add A and B, or subtract A and B. Just leave it over C, okay? So these are real easy. What's 7 plus 3? 10. So all it is 10 over 4x. But is there a number that goes into 10 and 4? 2. So we need to simplify it. So 10 divided by 2 is 5, and 4 divided by 2 is 2. Okay? So make sure your final answer is in simplest form or reduced. Okay? That one pretty easy, right? Common denominators is pretty easy. Here we got common. Let me do this for you guys so that you can, if you're writing down that one, you can see both of them. All right. Do we have a common denominator again? Yes. Right. So that just stays x plus 6. That doesn't change. And then what's 2x minus 5? Just 2x minus 5. They're not like terms, are they? So just write 2x minus 5. Can you factor either one of those? Top or bottom? Nope. So you're done. Simple. Okay, nothing we could do there. But if I could factor either one, you should factor them because you might be able to cancel common factors like we did last week. Okay? So if it's already got a common denominator, they're really easy. Just add or subtract numerators. Okay? When you have unlike denominators, you have to find the common denominator. It says rewrite each rational expression using the common denominator, then add or subtract. So you have to rewrite them if they're not with a common denominator, like the first two. Okay? Now, when we do this, all we do is factor denominators to start. Don't factor any numerators. That's very important. Just going to factor what? Say it back to me. Denominators. Okay? Just factor denominators, Trip. All right? You can always find a common denominator by multiplying the denominators if you want. Okay? But factor first. It's much easier. Okay? But basically what we're doing is finding the least common multiple. Okay? All right? So I want to show you how to do this. All right. So can I factor the first denominator? No. Okay. How about this second one? Yes. GCF is 3x. 3x squared divided by 3x is x. And 3x divided by 3x is 1. Okay? So, you need to write down what shows up then. All right? I see a 9x squared show up. And 3x goes into 9x squared, doesn't it? So I don't have to rewrite this 3x. Okay, this is, 3 times 3 times x, right? All right, or we could say it's 3 squared or an x squared. All right, so I see a 3 show up, an x show up, and an x plus 1 show up. And then if there's any exponents, you write the higher exponent. So what's higher, 3 to the first or 3 to the second? 3 to the second. X squared or x? X squared. So there's our common denominator. Okay? That's if I factored it all out for you. So whatever factor shows up, you write it down. Doesn't have to be in both sides. If it shows up, you write it down. If it shows up more than once, you don't have to write it down more than once. If any exponents show up, like this one, write the higher one. So we use the 2's for the 3 and the x. Okay? So, this is my common denominator now. I have to rewrite my numerators. So, what changed from this original to this new denominator? What changed? I already got the 9. I already got the x squared. What changed? What did I multiply by? This, right? So what do I have to multiply 7 by? The same thing. All right. Here, what did I multiply by? From 3 to 3 squared, I multiplied by what? How do I get from 3 to 3 squared? Multiplied by 3. How do I get from x to x squared? I multiplied by x. So I multiplied by 3x, right? To get from here to here, I multiplied by 3x. So I have to multiply that x by 3x. Any questions on how I rewrote the two fractions? Whatever you do to the original denominator, you have to do to the original numerator when you rewrite your fractions. Okay? Now what I do is I distribute and multiply. Okay? So I'm going to rewrite these one more time just with my distributed part. 7x plus 7. And I'm going to write 3 squared is 9. Just so it looks a little better. That doesn't change once you figure out what it is. That's going to stay the same. Okay? These two. So I distributed the 7. What's x times 3x? 3x squared, right? So there's my two fractions now, rewritten with my common denominator. Now it looks like a problem of the first two we did. We could just add the numerators. Any like terms in the numerators? No. So just write it out in the right order. 3x squared would be first, plus 7x plus 7. Okay? Now at this point, you should try to factor the numerator. Okay? Don't factor any numerators until after you add or subtract. So the rule is to try to factor this is to multiply those two, which is 21. All right, 21 is 1 times 21 or 3 times 7. That's it. Well, any of those add up to 7? No. So can I factor it? No. So I'm done. Okay. Since I couldn't factor that numerator and try to simplify that fraction, I'm done. So we had to rewrite the two fractions with the common denominator before I could add them. Okay, any questions about any part of that? So factored denominators first, and then whatever factor shows up, you write it down. it shows up more than once, you don't have to write it more than once. Okay, but if there's exponents like this one had, you write the higher exponent that shows up. Are you paying attention? That doesn't matter. Are you actually paying attention? Good. All right. Can I factor either denominator? Yeah. What's common to the second denominator? 3. What's that thing called? Perfect squares, or difference of squares, right? Okay. So, my common denominator. What shows up? I see a 3 show up. I see an x squared show up. There's a 3. Do I have to rewrite it again? No. If it shows up, you don't have to, again, you don't have to write it again. I see an x plus 2 and an x minus 2. So whatever shows up, you write down. So I saw that 3, that x squared, because that's all you could do, right? It's not factorable. 3 showed up again. I don't have to write it again. An x plus 2 and an x minus 2 showed up. You got to write them down. That's my common denominator. So, looking at this original, what did I multiply by? That x plus 2 and x minus 2, right? So that's what I have to multiply 1 by, which just means x plus 2 and x minus 2. The 1's not going to change anything, is it? All right. So here's the original. Here's our new one. Our common one. So here's the 3. I see the 3. Let's do it in red. The 3. The x plus 2. That was already there. So what did I multiply that bottom by? What's different or extra? The x squared. So I have to multiply that x by the x squared. What is x times x squared? X cubed. You with me? Any questions? Okay. Okay. All right. Skylar. All right. So there was an x there here. And then what was extra was this x squared. So I multiplied those two together to get that x cubed. Okay. Now, before I can add these, I have to do multiplication before I can do addition. All right. So I have to FOIL that. We already know what that equals, right? What's x plus 2 times x minus 2? X squared minus 4, right? Kaylee? You all right? If I FOIL it, I get x squared, then outside is negative 2x and inside is positive 2x. What happens to them? They cancel, right? And then 2 times negative 2 is negative 4. Maddie?
Why don't they cancel?
Here, because then I go right back to where I started. Okay? So you're not doing any simplifying because we're rewriting these fractions with common denominator. That's what I'm saying. If I cancel those, I go right back to 1 over 3x squared, where I started. So I don't want to do any canceling until I get it added. All right? That's why we don't do any factoring of the numerator. When we factor denominators, to start, rewrite our numerators, do what multiplication you can do. Now we can add them. Okay? So I got an x cubed plus an x squared, and then negative 4 plus nothing is negative 4. And And then my bottom is 3, x squared, x plus 2, x minus 2. All right, this won't factor this trinomial up here. If we had a 4x, we could pull out an x and then maybe do something, but that's not going to factor. So we're done. So on these that don't have common denominators, we have to rewrite them with a common denominator before we can add or subtract them. Questions on that one? Okay, let's look at another one. All right, factoring this one, 2 comes out. This one would be x minus 1 and x minus 3. Negative 1 times negative 3 is a positive 3, and negative 1 plus negative 3 is a negative 4. Okay, so my common denominator is whatever shows up. I see a 2, I see an x minus 1, I see x minus 1 again, I don't have to write it again, and I see an x minus 3. So that's my common denominator. Whatever shows up, you write down. Okay. So what do I got to multiply x plus 2 by? Look at what I had originally and what I did to it. What did I multiply the old denominator by to get my common denominator? I usually say, what's different? I see a 2 and an x plus 1. What's different? The x minus 3, right? So I multiply x plus 2 times that x minus 3. What's different from this original to the new one? Multiplied by what? The 2. So I multiply that original by 2. Questions? Someone else? Kaylee. This x plus 2 here? It was here in the original problem, the original numerator. So that's still part of my numerator. I just have to multiply whatever I did to the original denominator, I also have to do to the original numerator in both of them. Whatever I did. So here I multiplied by x minus 3, so I have to do that by that. Here I multiplied by 2, so I have to multiply that original by 2. All right? Now I'm going to FOIL the left numerator. I'm going to distribute on the right. Okay? So let's rewrite it in a different color. So I got x squared minus 3x for outside, inside plus 2x, and last minus 6. I'm going to treat this as a negative 2 because of this minus sign. I'm going to do this. You guys okay with that? So negative 2 times negative 2x is a positive 4x. And negative 2 times negative 1 is a positive 2. So now I'm going to rewrite, or actually I changed it to addition. I made that plus negative 2 and distributed the negative 2. All right, so combining my terms, I got an x squared, no other x squareds. I got negative 3x plus 2x is negative 1x plus 4x is 3x. And I got negative 6 plus 2 is negative 4. Can I factor that numerator now? Are there factors of negative 4 that add up to positive 3? There is, right? What are they? 1 and 4. Which one's positive, which one's negative? Thanks. You didn't need a pass, did you?
No. 4 and negative 1.
Positive 4 and negative 1, right. So now Do we see common factors? We do, don't we? So our final answer, x plus 4 is in the top, and then the 2 and the x minus 3 is in the bottom. Questions? These aren't that hard, but it takes some time because you got to rewrite everything. That's what takes some time. You guys did pretty good at the factoring stuff on the quiz we had Thursday. So the factoring part shouldn't be a problem. Just figuring out what your common denominator is. And then rewriting, and then adding or subtracting. Okay, so again, I'm going to factor. There's only denominators, okay? So x minus 1 and x minus 2 gives me that trinomial. Negative 1 times negative 2 is the positive 2. Negative 1 plus negative 2 is the negative 3. I got a GCF of 2. Divide 2x by 2, I get x. Negative 4 divided by 2, I get negative 2. So, Brett, what's my common denominator?
Well, you can factor the 1 to...
Already got them factored. Look at the green stuff. Whatever shows up, write down. So what do I have to write down?
X minus 2.
Yeah, what else? What else showed up?
2.
Did you say 2?
Yeah.
Yeah, what else?
X minus 1.
Right. Whatever shows up, you write down. Again, it really doesn't matter what order. But if it shows up, you got to write it down. So, here's our original denominator. What's different? What did I multiply by to get the common denominator? Look at this. What's in the red box? Look at this one. The 2, right? You guys see that? So I have to multiply this by 2. That 5x minus 1. Okay. Here's the original denominator. What did I do to that? I multiplied by what? That x minus 1. You guys see that? See that? What's different between the two? So I have to multiply that original numerator by that x minus 1. Okay? So I got to do multiplication before I can subtract. Again, once I get my common denominator, that's not going to change until maybe the very end if I can simplify my answer. Okay? So, distribute the 2. FOIL negative 2x squared plus 2x minus 1x plus 1. So now I'm going to combine like terms. There's no x squareds over here. So what's nothing minus a negative 2x squared? 0 minus a negative 2x squared. Minus a negative is what? Addition, right? So it's a positive 2x squared. 10x minus, well, let's put these two together. What's 2x minus 1x? 1x, right? So what's 10x minus 1x? 9x. What's negative 2 minus 1? negative 3. There's my new numerator after I subtracted them. Now, I should try to multiply these. 6 times negative 3 to try to factor it. There's no GCF. So 6 times negative 3 is, 2 times negative 3 is negative 6. You got negative 1 and a 6, or 1 and negative 6. You've got 2 and negative 3, or negative 2 and 3. Will any of those add up to 9? No, so we're done. We can't factor that numerator and try to simplify that. So that's adding and subtracting rational expressions, or we call them fractions. Okay? You need a common denominator. All right. There's one of the homework assignments. Again, you can look online or you can write it down quick. But I got something else I got to show you. We're not done yet, Pete Belucci. Again, when's this due? Thursday is correct. You got it written down, everybody? Connor? Just about? Alex? I got it. Drew? All right, you ready? All right. So, the other one. Part 2. Come on. Let's just do this, I guess. All right, we already done this, right? So that's stuff we've learned. All right, complex. Complex fractions is a fraction that contains a fraction in its numerator and denominator. So it's like a fraction divided by a fraction, basically. All right, so it says, if necessary, simplify numerator and denominator by writing each as a single fraction, then divide by multiplying by the reciprocal. Or you can multiply the numerator and the denominator by the least common denominator of every fraction in the numerator and denominator, and then simplify it. All right, so let's see. All right. So when I usually do these, I just, if I have addition or subtraction in one of them or both of them, I find those answers first. Okay, so I'm going to do this problem. I thought I was. This problem first. All right. Can I factor either of those denominators? No. So I just write them both down as my common denominator. Whatever shows up, you got to write down. All right. So what did I multiply the original numerator or denominator by? X. So what's 1 times x? X. What did I multiply this original denominator by? So I got to multiply the 2 times x plus 4. Distribute, just like we were doing. What's 1x plus 2x? 3x. What's nothing plus 8? 8. All right, so that's what this turned into. So here's my problem now. This fraction over this fraction. Basically, I'm dividing 2 fractions now. All right, what did we learn last week? If you're dividing a fraction by another fraction, you can turn it into multiplying by its reciprocal, right? So I'm going to move this up there. But remember, I like to put the x in front. That just bothers me. But you don't have to. You can leave it like I had it. So that's my problem. You see any common factors you can cancel? Yeah, what? X plus 4s, right? So the top is 5x. And the bottom is 3x plus 8. We just simplified that complex fraction. So we did this addition problem in the denominator and made it a single fraction. So then we have a fraction divided by a fraction, which we turn into multiplying by the reciprocal. That's how you take care of complex fractions. They're a fraction within a fraction. Scott, I see you're paying close attention, not playing with your phone. Thanks for doing that. I appreciate it. What's the common denominator in the top? Nope. Nope.
3x.
Nope. What does 3 and 6 both go into? Go into, not goes into it. They both go into, they do 12, but what's smaller? 6, yeah. What about 5 and 10? What do they both go into? 10. All right, so this stayed the same, so that doesn't change. What did I multiply 3 by to get 6? 2. So what's x times 2? What am I multiply 5 by to get 10? So x times 2, 2x. And that didn't change, right? We okay so far? Those are pretty easy because 3 goes into 3. I'm sorry. 3 goes into 6, 6 goes into 6, 5 goes into 10, 10 goes into 10. All right? So this problem now, what's 1x minus 2x? Negative x. What's 2x minus 7? 2x minus 7. So there's what it looks like now. One fraction divided by another fraction. So I'm going to multiply by the reciprocal. So the top one doesn't change. The bottom one flips. What goes into 6 and 10? What number? 2, right? So 2 into 6 is 3. 2 into 10 is 5. Nothing else. I can't factor that 2x minus 7. I can't cancel this x with that x because of that minus sign. Okay? If that was just, just a 2x or maybe a negative 14x, whatever, then we could cancel the x's, but we can't. So the top is just negative x times 5 is negative 5x. And the bottom is just 3 times 2x minus 7. You don't have to distribute the 3. So simplify the top and the bottom like you have learned. And then you have a fraction divided by a fraction, so you multiply by the reciprocal. Right, Brendan? So multiplying by the reciprocal you did on the last quiz. We're supposed to. Some of you forgot to flip it. Okay. And what some of you did on that last one was you tried to cancel stuff when they were both in the bottom. You had an x plus 2 in the both bottoms after you simplified and you tried to cancel it. Right? You can't do that. Right? You got to be one in the top, one in the bottom. Right? One in the top, one in the bottom. All right. So this is like 4 over 1, and that's like 3 over 1. So what's the common denominator? What shows up? You see an x and a 1. So what do you get when you got multiply x and 1? 1x, right? So if I make this an x, I got to put an x up there. Whatever I did at the bottom, I got to do the top. You with me? Okay. So this is 2 minus 4x over x. And this is 2 plus 3x over x. Okay. So 2 minus 4x over x times x over 2 plus 3x. That plus looks bad, sorry. I could factor a 2 out and get 2 minus, or 1 minus 2x, but I can't factor a 2 out of here, so I'm not going to worry about that. Only thing I can cancel is this and this. So 2 minus 4x over 2 plus 3x. Okay, so that's everything. Adding and subtracting fractions and simplifying a complex fraction. Okay, you have to factor numerators first on the addition and subtraction. I'm sorry, I lied. Factor denominators first. Do not factor numerators, right? Then rewrite your fractions with their common denominator, then add or subtract. After you do that addition or subtraction, then you can try to factor the numerator to simplify. On these, whatever problems you got to do that first in the top or the bottom or both, like that one. And after you do that, multiply by the reciprocal. Okay? Here's the other assignment. 2, 4, 6, 16, 18, 20, 22, that's 7, 36, 38, 40, that's 10 there. It's not that bad. The other one's about, 7 or 8 problems, and the other one's 10. Due Thursday. You guys have any questions? Okay. All right. Thanks for your attention.